Hello and welcome to my third and final video on empirical formulae. This video is about molecular formulae, which is a slight extension of the empirical formulae stuff we've been doing before. Again, this is useful for students who are doing the IB for chemistry, and if you're doing grade 10 or year 11 chemistry, hopefully it'll be useful for you too. So, the link to the IB is quite explicit. Again, it's part of 1.2, which is the mole concept around from unit 1, which is stoichiometric relationships. And it's part of the applications and skills. And the particular part it refers to is the determination of the molecular formula of a compound from its empirical formula and molar mass. Right, the clue is there. The empirical formula is something which you need, which we've calculated in previous videos, and the molar mass is usually something they give you. So, just to kind of reiterate what I've said in earlier videos, the distinction between empirical and molecular formula. So an empirical formula is the lowest whole number ratio of atoms in a compound. The molecular formula is the true number. So as an example, molecular formula, you can consider it to be the empirical formula multiplied by this number n. So if you consider benzene, which is C6H6, the empirical formula is CH, and it's multiplied by this number n, which in this case is 6, so the empirical formula is CH. So let's go through some basic problems first of determining molecular formulae. So here's a typical problem you might get. The empirical formula for an unknown compound is CH. However, other data confirms that it has an MR of 65. What is the molecular formula of this compound? So you need the empirical formula, and they've given that to you already. It's CH. You also need the molar mass, which is 65. So you've got both bits of information, so you can actually work out the molecular formula. Now there's a number of basic steps that you need to take in order to work it out, and I'll go through each one at a time. The first one is determining the empirical formula. You have to know what it is. Now sometimes you have to calculate it, sometimes you don't. In this case you don't. We know it's CH, so I'm just going to write it down. Step 2 is to find the formula mass of that empirical formula. So carbon is 12.01 from my data book, and hydrogen, also from my data book, is 1.01. So that equals 13.02. My third step is I have to divide the molar mass by the mass given by the empirical formula. And I'm worried that one of my animations is going to cover what I've written, but that's not too bad. So the molecular formula divided by the empirical formula mass-wise is going to give you this subscript multiplying factor. Now my MR is 65, so that's my molecular formula mass. My empirical formula mass is what I worked out over here, is 13.02. So 65 divided by 13.02 gives me 4.99 ... which is basically 5. All right. Therefore, my molecular mass is going to be CH brackets 5, which equals C5H5. Okay. It's as simple as that. And if you follow these steps, you can't go wrong. And I've just done that final step here. That's step 4. All right. So here's another example. Please pause the video and have a go at this first on your own, and I'll go through the answer with you in a moment. Okay, so hopefully you've had a go at that. So let's go through the steps which we went through in our last example. First off, determine the empirical formula. Again, it's been given to you, so it's C3H5O2. Step 2, find the formula mass of the empirical formula. So it's 12.01 times 3 plus 1.01 times 5 plus 16.00 times 2. Remember again to use your data book. So that would be 36.03 plus 5.05 plus 32.00, which will then equal, let's put that in, I've got 73.08. Right. So my next step is to divide the molecular mass by the mass given by the empirical formula. Again, it's what I showed you before. So the mass of my molecular formula is 146. That's been given to me in the question. I then have to divide that by my empirical formula mass, which is 73.08. Doing that calculation gives me 1 1.99781 ... which equates to 2. So, just to finish off, I have to multiply my empirical formula by that number to get the molecular formula. So, my empirical formula is C3H5O2, and I times that whole thing by this number, which will equal 3 lots of 2 is 6, so it's C6, 2 lots of 5 is 10, H10, and 2 lots of 2 is 4, O4. So there you have it. That's your solution. Okay, so now let's do another example where instead of doing the basic stuff I've just shown you before, you now have to combine that with the empirical formulae skill which you've learned from a previous video or from in class, wherever you've done. So here's a question. An oxide of chromium is found to have the following percentage composition. It also has a mass of that. Determine this compound's empirical and molecular formula. So I'm going to give you a moment first of all. Just pause the video and try and determine the empirical formula, and then I'll play, and then play again, and we'll go for the answer. So to determine the empirical formula, this is how you do it. So the first step is percent to mass. Remember that, I'm just going to change my ink color, that you have to consider with percentages that you have 100 grams of the substance to kind of take away the percentage complication. So I've got chromium and I've got oxygen. I've got 68.4 and I've got 31.6 there. I've also got the AR, I can put that in now while I'm here. Chromium, using my data booklet, is 52, bang on. And oxygen is also 16. So to work out the moles, that's my next step, mass to mole, I have to divide the mass, or percentage in this case, by the AR. So it's 68.4 divided by 52, and that gives me 1.31538 ... In this case it's 31.6 divided by 16 gives me 1.975. Okay, bigger number. Remember, always show your working. So now I have to divide by small. My smallest number is here, so that's going to equal 1. So 1.31 over 1.315 equals 1. In this case, it's going to be slightly different. So 1.975 divided by 1.315 will equal basically 1.5019 and so on, which equates to 1.5. Okay. Last step is to multiply till whole. So if I'm going to multiply this to whole, I need to get rid of this 1.5. So timesing it by 2 I think is going to work. So 1 times 2 equals 2, and then 1.5 times 2 equals 3. So my empirical formula is Cr2O3. Now, I need to work out my molecular formula, and that's what I'm going to do on the next page. This equation is going to come in very handy a little bit later on, but we'll go through it kind of one step at a time. Remember our formula, I'm just going to write it here just so I don't forget, it's Cr2O3. So my first step is determine the empirical formula. I've done that. Step 2, find the formula mass of the empirical formula. Ignore that. So the formula mass of this, I now have to work out. So the MR, if you like, is going to equal 2 lots of 52 plus 3 lots of 16, which equals 152. Okay. My third step is to divide the molecular mass by the mass given by the empirical formula, and that's this equation here. So I have to do 150, well, 152 is at the bottom, which is there. And if you look at the question that we looked at before, it's 304. So I'm just going to put in 304 there, divided by 152, and that gives me 2, bang on 2. And my final step, I have to multiply the empirical formula by that number to get the molecular. Now my empirical formula is Cr2O3. I times it by 2, so it's Cr4O6. And that's how you do it. So I hope this video has been useful for helping you to work out how to determine molecular formula. Best luck with your future calculations.